In this video we are going to talk about linear inequalities. Right. For x equals 5, for example, we know the value of the unknown x, it's 5. Or if you're solving an equation like 2x minus 3 equals, say, 9, then you add 3 to both sides, and then you get 2x to be 12, and then you divide by 2, and then you get x to be 6. Now in these cases you have only one solution for the equation, right? Because this is an equation, whereas if you have the same thing here, let's write 2x minus 3 is, let's say, less than 9, right? Actually, what you're going to do is the same thing as in the equation. So you're going to do plus 3 for both sides, and then you get rid of these 3's, as in here, right? And then it's going to be 2x less than 12, and then you divide by 2 to cancel 2's, and then you get x less than 6. Now, this gives you a lot of solutions, actually infinitely many, which is, even if you consider the integer solution, it's going to be like, it will be from the negative infinity to until 5, because it's not equals to 6, right? It's only smaller than 6. So these will be, all these infinitely many numbers, integers, will be a solution, let alone, say, the real numbers. So basically what we do is the same, and what we find as an answer is called as a solution set, because it's a group of numbers for the solution of this inequality. Probably you know these, but we use these signs to write down inequalities. So it's going to be less than, greater than, less than or equal to, greater than or equal to, which is slightly different. The difference is that if you write x is less than 5, then 5 is not a solution, whereas if you write x is less than or equal to 5, then 5 is a solution. Now let's look at these examples. So it's 10x plus 43, which is 13. I have to leave x alone, so I'm going to go like minus 43 from both sides, and then I'm going to end up with 10x is less than minus 30, and then we divide both sides by 10, and we get x being less than minus 3. So that's the answer. Now we can illustrate this, we can show this on a number line like this. So I'm going to put a hollow circle to show that minus 3 is not in the solution, and then I'm going to mark all this bit, which are the numbers smaller than minus 3, to show that they are in the solution. Of course, this is going to be connected. Now, one thing is very important. This is a hollow circle, empty circle, if it's strictly equal here, and if it is equal like this one, then you have to fill the circle. Another thing is that if you're drawing this number line, you don't write all the numbers, or you make a big one, right, big number line. It's going to be something small, where your solution, the border here, will be around the middle of the line, right? So let's look at this one, the second one. In this one, I have to collect x's at one side and numbers on the other side. So it's going to be like, I'm going to be taking this minus x to the other side and 6 to the right hand side. So it's going to be x plus x less than 10 minus 6, and then it's going to be 2x less than 4. Dividing by 2, you get x less than 2. And if you show this on a number line, it's gonna be something like this. So you can write down like 0, 1, 2, 3, 4, and then you can say your solution is from 2, that's an empty circle, and it's gonna be through the left hand side. This is how you can show your solution on the number line. So if the sign of this inequality would be like greater than, then I would be showing my solution like the same border with empty circle, but it's going to be this way, right, because it's greater than. And in the case that I have the equal sign here under the inequality, so this is going to be less than or equal to, then I would be having this full circle here to indicate that this solution, the border, is in the solution. Now is your turn. Please solve these inequalities together with the number lines on your book and then submit your answers online.